My name is Larry Goot, and for the past almost 20 years I've been a professor of entomology at Michigan State University in the United States. I am officially the tree fruit entomologist, so I have responsibility for managing pests of apples, peaches, cherries, and pears in Michigan. Pretty big industries. My specialty, which I've been working on for now 40 years, is the use of semiochemicals in managing pests, both for control and for monitoring. In particular, ow, my eye hurts, sorry. Tree fruit pests, and in particular mating disruption has been my specialty with my first experience with mating disruption in 1977. And then in 1991 I was hired with responsibility to develop mating disruption for the state of Washington with Jay Bruner, and that's what I do. So the main alternatives that are being used in the systems that I work on are mating disruption, because tree fruit is the large success for mating disruption. Fruit crops in general are the big success for mating disruption. There is quite a bit of interest in use of viruses, insect viruses, and insect bacteria that affect insects. So that's still quite a bit of efficacy in tree fruit crops and probably in other crops around the world. Other biologicals, not so much, except just relying on natural enemies that are already there because we time our sprays properly, or we put pheromone in and then we count on biological control. But really, from an alternative standpoint, mating disruption has been the big player for fruit crops, the big success. Biological control has introduction of natural enemies has not been, well, actually that's not true. So introduction of natural enemies for pests that directly affect the crop have been very limited in terms of success, because you have to get the population down so low that biological control kind of just leaves you at a level where you get more damage than you can sustain. But in my crops, biological control has been very successful for spider mites. I don't know if you have spider mite problems here, but spider mites and biological control have been a huge success in tree fruits. Probably, if you don't mess things up by spraying improperly, you get biological control of spider mites, and you can release natural enemies for spider mites, and they work very well. And there's several other insects where biological control has worked very well. Leaf miners, very well. All of those have really blossomed with the advent of mating disruption. So when we start to pull out all the insecticides that we don't need anymore from using pheromones in tree fruit crops, then biological control is a viable option, and so it's become more important to those systems. I give you the roughly because I just wrote an article on it actually. It's probably roughly in the range of maybe 20 different insects, somewhere around between 15 and 25 different insects being used, and there are six or seven that make up 90% of the area that's adopted mating disruption in the world. Mating disruption is the one big commercial success. The other would be track and kill, which has mostly been adopted for fruit flies successfully, and I don't work very much with fruit flies, but I know it's been quite a success. How many do we have? I think people tell me we have over 2,000 now that have been identified. I don't know if they can all be produced because some of them are very expensive. There's many potential targets of semiochemicals that have been stopped basically in their tracks because the synthesis of the pheromone is so expensive. Is that 1%? Yeah, 1%. 1%. Yeah, it's probably less than that, but yeah, 1%.
The 6 are the big ones.
Yeah?
The 6 out of them is 90%.
Yeah, probably 90%.
So let's keep to 1%. Otherwise, it's really ridiculous.
It is ridiculous. It's pretty amazing. If you go to the meetings where the experts show up, you have a super attendance when you have 300 people in the world. So there's probably 500 or 600. Why there's 2,000 or more pheromones and we only have products for 1%. which I don't really know the answer, except I think it's twofold. I think one is that most of the research counts on universities, government institutions, federal institutions, and there's only so much resources to put into particular areas to do research, and they decide where to put them, and that's how many people are working in the area. And I think the other one is there was a chemical company person that gave a talk I thought was pretty interesting, just talking about what the market is, how they see the market. And right now there's not a very developed market for semiochemicals. There hasn't been, because they're expensive. And so I think that's really deterred having more companies pop up and more interest in it. It's difficult. Yes, because cost is the big impediment to growers adopting it worldwide. So if you could reduce the cost just 50%, I think it would really dramatically increase the interest in the adoption, if the technology was there. For the technologies that are there now, it's all about cost. They're very expensive. For a few insects, a very high percentage. But for most insects, it's around 50 or 60%. Labor goes right in there with cost, so labor's been a big impediment. Growers really want to have a delivery system that requires very little labor, because labor's expensive. Mating disruption, that's been a big impediment. And that's been the drive for new technology. All companies are trying to come up with technologies that are much less labor intensive. I say, especially from the one slide you showed me about the issues in delivery systems that you're trying to address, I thought they were well thought out, and they are the issues that need to be addressed. Like a delivery system that doesn't require that the actual release, you're controlling the release manually. That the release is not just dependent on evaporation and figuring out how to get it to come out properly. That you're basically mechanically deciding what the release is going to be. I think that's an important thing. You don't want me to answer that question. I'm a biased researcher. I think there has to be some nice independent evaluation of what's going on, and knowledge outside of your company's knowledge of the product, so it gets a good look at it. People get excited about it. That's how products move forward, with independent evaluations, and independent look at them. In my job, there is insecticides. We do efficacy testing, and we put out a book. The university puts out a book to make recommendations. Grades State puts out a book to make recommendations. If this is my way I work, and I don't know how grade works, but if those companies show me data that's done by companies themselves, or companies that I don't know very well or I don't have a lot of faith in, I refuse to put that in my personal recommendation guide. If I'm going to suggest something for the growers that I work with, I either have to evaluate it myself, or I have to have it evaluated by people that I have great confidence in what they've done. So if Greg shows me a bunch of tests, then I say, okay, I think I can make a recommendation on it in my own guide, even though I haven't tested it. Or a few other people, but I have a very limited set of people that I say are giving it an unbiased, independent evaluation. And those companies can show me all the farmer reports until they squirm. I think the only other thing is the thing you and I talked about. I think it's really important. You asked me about impediments to moving semiochemicals forward. I've been doing this for 40 years. Please stay out of there. I think some sort of realistic look at the regulations around some of these chemicals, some kind of international harmonization of what those rules might be like, because I think some of the chemicals are not the same as insecticides, even though they're treated worldwide like that. You know, they're pretty much known, natural, benign compounds that are going out in incredibly small quantities, not the quantities we're putting pesticides out. They break down rapidly. They're volatile. They disappear. And the burden of those regulations on smaller companies that are trying to develop these things is really impeding the world's ability to move to safe pest management. It's really too bad.